Hello everyone, just to welcome back to my short clips, hopefully to recap of what was broadcast on YouTube Live on yesterday on March 17, and sorry to realize that it wasn't such a clear stream. So anyway, I hope to come up with a few short clips upload on YouTube and then talk with you live next time on next week on 14 o'clock to 16 o'clock live in case you have questions. But in the meanwhile, just to make sure that at least you try to check out some of the short clips that I post as well as the PowerPoint, and you also can have a chance to look at the old e-learning clips of previous semester about the clustering. Okay, so just to keep you active, so every Friday I should come up a small quiz or exercise on Edmodo, and hopefully make sure you post back either the quiz answer or the short exercise on the Edmodo by the following Sunday of the immediate Friday. Okay, so let's get into it. So overall clustering, I hope that right now I would make you the first short clip of the overview, what is the clustering, okay, and the details about it. And later on we will have another clip about the partition-based clustering, such as the k-means algorithm, and another clip on hierarchical clustering, and with all the varieties of them. And the next week there will be the entire lectures, so self-organizing map. Hopefully I will have at least one clip or multiple of them, who knows. But after that, as a part of week 12, I will have kind of combined labs of all variety of clustering into one Python lab. Okay, so hopefully that should include every bit of different style of clustering for you. So first, let's get into the major idea of clustering. Okay, clustering is the basic task, basic form of knowledge in any data set you have. That is, we try to find the natural grouping of the data items that have been given to you. And it also have another name in the machine learning sub-area of AI. You might heard another word, it will be called unsupervised learning. Okay, because the data is given to you as is, there is no additional need to label the data before you perform any training or perform studying. Okay, and let's look into some of the possible samples of clusterings, and we'll come back later with how to tell whether which one is a good result, which one is not so good result. Okay, so first let's look at, here is what given to you on here. Okay, input any set of data point, given data points. Okay, so you can see that here there's no boundary drawn, but after the clustering is done, the output start to have a well-defined boundary. Okay, sometimes people call this cluster boundary. And in this example, you can see that each boundary of 3 clusters, they're not overlap. Okay, so that is a good thing. And on top of the cluster boundary, we can also compute a virtual midpoint inside each cluster. We would call this technical name, they call cluster center, which become useful when we want to refer to the main behavior of each cluster in the future. For example, a bank could describe a customer with low income such that the average income of low income cluster is around 10,000 baht. per month, for example. So you get the idea how the behavior of low income segment of customers are like. Okay. However, cluster doesn't need to have perfect shape like round. It can be non-round or non-spherical as well. Okay. And in this example is the example of you have two clusters. Okay. Or a lot of time people refer to it as the parameter k, or k equal to 2. Another major behaviors or properties of cluster is how it spread in relative to other member of other cluster. In this case, you can see that there are high degree of overlapping. Like those are the boundary of the yellow, and these are the boundary of the dark kind of reddish purple, and there could be more boundary of the green data points there, and there could be more boundary of the dark blue data point. Okay, so in this example, these are the example of overlap cluster, which is not ideal but could happen in many real-world applications. Okay, so if it's not ideal, what do we want in good cluster? Okay, so now I'm back to tell you more in terms of the good properties. We are looking at two things. First, it has to have low intra-variance among them. Okay, so this quality talking about compactness. Compactness within cluster. The second properties that we need to maintain for goodness of clustering result is high inter-variance between clusters. Okay, so these are number 2. This ensures that it has minimum overlap. Which means the cluster result have no confusion. Okay, so let's look at the example. Okay, for example, furthermore, picture A on the left definitely is the ideal cluster, because you can see that if you draw cluster boundary, you can see that if that's the dark spot represent the virtual cluster center, you can see that there are high density, there are many members tied together. So definitely this shows it has the low intra-variance within cluster, within each cluster. Okay, or another word is compact. And at the same time, we can see right away that if I draw the straight line link between two cluster center, you can see that it's quite far apart. So this is good thing because it implies that this has the high inter-variance. Among different cluster. So that means no chance that we could confuse between one data point having been to more than one cluster. So this is a clear cut. Okay, so the picture on the left is definitely ideal clustering, where the picture on the right in the picture B, you can see a high degree of overlap. And also there are a lot of empty space, so it's not compact. Okay, so the picture A is definitely an example of good clusters Okay, but in real life, you might find some degree of B. Okay, it's not ideal that we would see something like the left example every time. All right, so see you next time for the next clip of K-mean clustering. Thank you.